Sometimes we want to be able to create a simple callable object, usually to pass directly to a function, without the bureaucratic overhead of the def statement and the code block it introduces. Indeed, in many cases it's not even necessary for the callable object to be bound to a name if we're passing it directly to a function. An anonymous function object would suffice. This is where the lambda construct comes into play, and used with care it can make for some expressive and concise code. However, as with comprehensions, excessive use of lambdas can serve to obfuscate rather than clarify code, running counter to the Pythonic principles which value readability so highly, so take care to deploy them wisely. If you're wondering why a technique for making callable objects from Python expressions is named after the 11th letter of the Greek alphabet, the origins go back to a foundational work in computing science in 1936 by Alonzo Church, predating electronic computers even. Church developed the lambda calculus, which forms the basis of the functional programming techniques used in languages such as Lisp. A good example of a Python function that expects a callable is the sorted built-in for sorting iterable series, which accepts an optional key argument, which must be a callable. For example, if we have a list of names in strings and we wish to sort them by second name, we need to pass a callable as the key argument of sorted, which will extract the second name. To do this, we can use a lambda to produce such a function without the bother of needing to think up a name for it. Let's create a list of scientist names: Marie Curie, Albert Einstein, Niels Bohr, Isaac Newton, Dmitri Mendeleev, Antoine Lavoisier, Carl Linnaeus, Alfred Wegener, and Charles Darwin. Now we'll produce a new list of sorted names using the sorted built-in and passing a lambda function as the key argument. Here our lambda accepts a single argument called name, and the body of the lambda, after the colon, calls the str.split method and returns the last element of the resulting sequence using negative indexing. Lambda is itself an expression which results in a callable object. We can see this by binding the result of the lambda expression to a named reference using assignment. We can see that the resulting object is a function, although it doesn't have a name, and that it is indeed callable like a function. Creating a callable function this way, using lambda and binding to a name through assignment, is equivalent to defining a regular function using def like this. Let's spend a moment to point up the differences between lambdas on the one hand and regular functions or methods on the other. Def is a statement which defines a function and has the effect of binding it to a name. Lambda is an expression which returns a function object. Regular functions must be given a name, whereas lambdas are anonymous. The argument list for functions is delimited by parentheses and separated by commas. The argument list for lambdas is terminated by a colon and separated by commas. Lambda arguments are without enclosing parentheses. Versions of Python predating Python 3 have special handling of tuples using tuple unpacking in the argument list. This confusing feature has been removed from Python 3, so in Python 3 code there are never any parentheses between the lambda keyword and the colon after the argument list. Both regular functions and lambda support 0 or more arguments. A zero-argument function uses empty parentheses for the argument list, whereas a zero-argument lambda places the colon immediately following the lambda keyword. The body of a regular function is a block containing statements, whereas the body of a lambda is an expression to be evaluated, and the lambda body can contain only a single expression, no statements. Any return value from a regular function must be explicitly returned using the return statement. No return statement is needed, or indeed allowed, in the lambda body. The return value will be the value of the supplied expression. Unlike regular functions, there is no simple way to document a lambda with a docstring. Regular functions can easily be tested using external testing tools because they can be fetched by name. Most lambdas can't be tested in this way, simply because they're anonymous and can't be retrieved. This points the way to a guideline to keep your lambdas simple enough that they're obviously correct by inspection.